Welcome to The Explainer, where we demystify the exact, step-by-step strategies you need to secure absolute maximum marks on your Cambridge computer science exams, specifically focusing today on IT 9626 Section 2.1. We are diving deep into the evaluation of mainframes and supercomputers, but we are doing it strictly through the lens of the examiner's playbook. I want you to think of your exam answer like a symphony. To score those top-tier marks, you must orchestrate your arguments perfectly, where every single paragraph acts as an instrument playing in total harmony. Now, to understand this, I want you to picture two typical candidates sitting in the exam hall right now, staring down a complex past paper question. Let's say it's from syllabus code 0417 or 9626. First, we have Alex. Alex is brilliant, but Alex overloads the paper with a massive brain dump of raw computer science facts. We're talking highly detailed technical specs about supercomputer liquid cooling systems, but absolutely zero contextual analysis. Then, on the other side of the hall, we have Sam. Sam is racing against the clock. Sam rushes through the paper, completely misses the specific command word requirements, and writes generic, vague answers that could apply to a smartphone just as easily as a mainframe. Today, we are going to look exactly at why both of those approaches completely fail, and I'm going to show you the precise framework to ensure you avoid their fate and walk away with top marks.
Let's start with a really powerful and honestly slightly intimidating quote directly from a senior examiner. This highlights exactly what's at stake today. They noted in a recent report that most students lose easy marks on 2.1, but after this explainer, you won't be one of them. So let's break down why students like Alex and Sam are bleeding these easy marks. When evaluating the pros and cons of mainframes versus supercomputers, the examiner isn't just looking for a memorized list of textbook features. If you are like Alex and you write a massive half-page paragraph about how supercomputers process quadrillions of floating-point operations per second, which is true, but the command word on the exam paper was evaluate, you are going to get 0 marks for analysis. Why? Because you described, you didn't evaluate. Likewise, if you're like Sam and you see a scenario about mainframes in a global banking context and you just write, they are really big and expensive, you have completely missed the mark. You're going to get your paper back covered in devastating red pen marks. But here's the good news. Those red marks are entirely avoidable if you understand the underlying strategy we're about to unpack.
Here is our tactical debrief for today's explainer. First, we'll cover the core theoretical principles. Second, we'll walk through the procedural framework. And third, we'll reveal critical examiner insights.
Okay, let's dive straight into Section 1, Core Theoretical Principles, Building the Foundation.
Before we can even begin to talk about the immense parallel processing power of a supercomputer or the incredible input/output bandwidth of a mainframe, we absolutely have to understand how Cambridge exams are designed to test your brain. The assessment objectives across syllabuses like 0478, 2210, 9618, and 9626 aren't just about raw recall. They target 3 highly specific cognitive domains, prioritizing deep analytical depth over superficial breadth. You are actively graded on knowledge and understanding, application, and analysis. To conquer these domains, top-tier students use what we call the PEAL framework. That stands for point, evidence, explanation, and link. You don't just state a fact, you orchestrate an argument. You make a clear point about a supercomputer's specific advantage. Then, you provide technical evidence of its underlying processing architecture. Next, you give a detailed explanation of how that architecture solves something incredibly complex, like real-time climate modeling. And finally, you link it directly back to the exact scenario provided in the exam question. That is how you hit all 3 cognitive domains in a single paragraph.
Now, what's really fascinating about this slide is how principal examiner reports explicitly state that candidates who make cross-topic connections achieve significantly higher grade boundaries. Isolated knowledge is simply stating a fact in a vacuum, like saying a mainframe is highly reliable and handles massive amounts of data. Honestly, it's a dead end. It won't get you to an A star. Cross-topic integration, on the other hand, means taking the advantages of mainframe computers from Section 2.1 and linking them directly to database management, network security, or enterprise software systems from entirely different parts of your syllabus. When you explain that a mainframe's real advantage in a centralized banking system isn't just its processing speed, but its ability to ensure atomic transactions and prevent database concurrency errors during millions of simultaneous ATM withdrawals, you are demonstrating the exact depth and mastery the examiner is desperate to see. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
A major hurdle, and I mean a massive roadblock for students, is navigating multi-stage analysis to secure those crucial method marks. Listen, method marks are awarded purely for the logical process, not just the final conclusion. Multi-stage analysis means your answer cannot be flat or one-dimensional. Let's play a quick interactive game of Spot the Peel. If a question asks for the disadvantages of a supercomputer, answer A says, it is very expensive to buy and run. Answer B says, the initial capital expenditure for a supercomputer is exorbitant, which is further compounded by the necessity for massive bespoke liquid cooling requirements and a team of specialized maintenance staff. Ultimately, this makes it financially unviable for anything other than massive government research bodies, effectively pricing out standard commercial enterprises. See the difference there? Answer A was an isolated fact. Answer B was a multi-stage analytical journey. That level of depth, showing the chain reaction of cause and effect, is exactly how you secure every single method mark available on the paper.
Let's move right into Section 2, the procedural framework, earning the method marks. Let's look at the actual step-by-step methodology.
This brilliantly illustrates what we call the computer science success blueprint. It is the exact 5-step method mark strategy you must use when tackling any examination question. We're going to mentally rewrite Alex and Sam's flawed answers right now, turning those red pen marks into green check marks. Step 1. Deconstruct the question to identify the command word and the subject. Is it asking you to describe, explain, or evaluate? Step 2. Extract relevant data from the scenario. Step 3. Select your analytical framework. This is where your Peel structure locks in. Step 4. Execute with clear logical notation. Step 5. Present with precise, accurate computer science terminology. Let's actually apply this blueprint live. Deconstruct. The command word is explain. Extract. The scenario is a national weather forecasting agency. Select framework. Peel. Execute and present. A major advantage of supercomputers for weather agencies is their massive parallel processing capabilities. They utilize thousands of multi-core processors simultaneously. This architecture allows the agency to calculate incredibly complex, multivariable meteorological models in real time, which is absolutely critical for issuing timely, life-saving severe weather warnings. Notice how perfectly that maps to the framework? That is an A-star answer.
Step 2 of that blueprint is incredibly critical. You must pull accurate data from the provided texts, charts, and tables to draw solid, evidence-based conclusions. Before we do a quick data scan challenge, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump into Challenge 1, Data Scan. Imagine we've put a complex data table on screen comparing the floating point operations per second, or flops, and the input-output throughput of a mainframe versus a supercomputer. You have a 60-second mental countdown. What is the core trend you need to extract from that data? If you scan the numbers, you'll notice a massive divergence. The supercomputer completely dominates in sheer brute force calculation speed, but the mainframe entirely outperforms it when it comes to concurrent I/O operations and handling thousands of simultaneous users. That specific relationship is exactly what you must interpret to draw evidence-based conclusions for your exam, rather than just copying numbers from the table.
Furthermore, when presenting your final answer, you must strictly follow professional formatting conventions to lock in your practical application marks. Proper headings help organize your thoughts and guide the examiner through your logic. Correct terminology shows you are a deeply informed student. You shouldn't just say, "it's fast." You need to use terms like throughput, fault tolerance, parallel processing architecture, and backward compatibility when discussing mainframes and supercomputers. Appropriate formats mean using clear bullet points if the question allows it, or structured, cohesive paragraphs for an evaluate or discuss command word. Clear annotation is essential if you are asked to diagram a system architecture. If you ignore these conventions, even if your answer is factually correct, you are going to bleed formatting marks, and we cannot afford to lose those.
Let's move into our final and perhaps most important section, Critical Examiner Insights, Avoiding Common Pitfalls. Let's look directly at the source. Listen to me very closely right now. These are the top 3 mistakes identified directly from the principal examiner reports that consistently, year after year, cost candidates easy marks. Let's jump into Challenge 2, Find the Flaw. I'm going to read a flawed sample paragraph, and I want you to identify exactly where the student lost the mark. Here we go. A disadvantage of a mainframe is that it is physically very large, which means it processes transactions much faster than a standard PC, making it good for banks. Did you catch it? Where is the flaw? The flaw is mistake number 1, confusing cause and effect. The physical external size of a mainframe is absolutely not the cause of its fast transaction processing. The cause is its specialized architectural design, its dedicated I/O channels, and its hyper-efficient operating system. The examiner notes specifically that students frequently confuse the superficial characteristics of a hardware system with the functional, technical causes of its performance. Don't fall into that trap.
To score at the top of the mark scheme, you have to transition your brain from a basic descriptive level to a higher order evaluative level. Descriptive answers simply state facts. Mainframes have hot swappable components. Okay, great, but so what? Evaluative answers weigh those facts against alternatives, always within a specific context. An evaluative answer looks like this. While supercomputers offer superior raw calculation speed, a mainframe's hot swappable components provide the continuous 24/7 uninterrupted uptime mandated by global financial institutions, making the mainframe the vastly superior choice for enterprise-level transaction processing. Now it's time for challenge 3, speed writing. If you are serious about this, pause this explainer right now and set a 30-second timer. Your goal is to write one perfect Peel paragraph evaluating a disadvantage of a supercomputer. Think about the massive power consumption, the specialized liquid cooling infrastructure, or the incredibly high cost of custom software development required to utilize parallel processing. Make your point, back it up with hard evidence, explain the real-world impact, and link it directly to a scenario.
Top-scoring candidates demonstrate this evaluative thinking constantly. They do this by questioning assumptions and justifying their decisions with hard, undeniable evidence from the scenario text. For instance, when the exam presents a scenario where a university wants to buy a massive supercomputer for research, don't just assume it's the automatically correct choice. Question the assumption. Consider different perspectives. Perhaps a distributed grid computing model, utilizing the idle processing power of thousands of standard student PCs across the campus network, would be vastly more cost-effective for their specific research needs. Justify your decisions with evidence, and always identify the limitations of the technology. A supercomputer's limitation isn't just its astronomical price tag, it's the fact that it requires incredibly specialized, bespoke software algorithms to actually take advantage of its parallel architecture. If you can explain the effect of that specific software limitation on the university's overall budget and project timeline, you are demonstrating the exact evaluative thinking that earns A-star marks.
So the most crucial takeaway from today is this blaring examiner alert. Never, ever give a generic answer. Every single thing you write must be intricately, undeniably linked to the specific context given in the question. If the exam scenario is about an international airline booking system and you write an absolutely brilliant, technically flawless paragraph about mainframe security, but you talk about protecting patient medical records in a hospital, you will get 0 marks. 0. The context is king. We've given you the complete analytical system today. We've shown you the 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix, allocating your minutes based strictly on the mark allocation of the question so you never end up rushing like Sam did.
As we wrap up this explainer, I want you to genuinely ask yourself, are you actively applying this 5-step framework and linking every point to the context in your past paper practice? But let's leave off with a much bigger, more provocative thought. We've spent all this time mastering how Cambridge examiners assess our understanding of mainframes in supercomputers today. But as quantum computing continues to rapidly develop out of its infancy, fundamentally shifting how we process complex, multivariable problems, how long until this entire examiner framework is completely upended? Will the very criteria for what makes a correct technological evaluation completely change in the next decade? It's something to think about as you continue your studies. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.